Thank you so much. It's great to get to participate in this event. Thank you to Chairman Pai for convening such a great group of academics, researchers, and industry professionals. And thank you as well to Secretary Pompeo for the remarks that you delivered today and for the leadership that you've been providing really around the world in furtherance of clean, secure 5G networks. This transition that we're doing right now to O-RAN is really a big deal. And to me, when I think about this transition, I think back to one of the great unbundlings that we saw, which of course is the PC market back in the 1980s. As someone that was born in 1979, I remember fondly those early 1980 days. If you think back to that period of time, IBM was just dominant in the PC market, and it was dominant in a way that was completely vertically integrated. Everything from the hardware to what we think of as the OS to the software was all packaged together. And with respect to the IBM of today, which is a very different company, and we'll hear from some of them to come, the upshot of that back then was a product that was clunky, that was expensive, and that really was only affordable from highly profitable corporations. And in the 1990s, Microsoft came in and completely disrupted that vertical integration. It unbundled the PC market. It separated out the hardware from the OS, from the software. And flash forward, we all know what that produced. That dramatically drove down the costs of laptops. It enabled a lot of different competitors to enter the market, from Dell to Gateway. And for consumers, it meant that they could actually afford to buy a PC. And that unbundling of the PC market coincided with the build out of internet infrastructure across the country. And you put those two together, and that's why I think we saw Americans getting onto the internet for the first time in the 1990s. And that exact same dynamic, that exact same type of unbundling is about to take place in the wireless infrastructure market. And so for those of us from a policy perspective, I think that's attractive for three main reasons. One is improvement in service. The other is improvement in security. And the other is jobs. And from the service perspective, this unbundling means that everything went from consumers to wireless carriers themselves are going to be able to mix and match components and pick the best ones that meet their needs. We're going to see competition across what used to be a vertically integrated market. And that's going to improve performance. We're already seeing pieces of that today. Right now, there's one rural carrier that's been working with an O-RAN vendor, and they're seeing a throughput increase by about 40%, and they're seeing their costs cut in half with a virtualized core plus O-RAN. So that's some of the reasons why this is going to be important. And we've been working at the FCC for a number of years now. I've been leading the effort to reform our wireless infrastructure rules to make it easier to swap out, upgrade, and add new equipment. And I think that's going to coincide with this desire to build out this O-RAN architecture. The other piece of this is jobs. So by unbundling, we open up the marketplace to smaller providers, for ones that are expert on software, and that happens to benefit a lot of U.S. companies, which I think is a great thing, particularly when we're talking about build outs that might be supported by universal service dollars. A lot of these companies are represented here today, from Altiostar to Mavenir, Parallel Wireless, and many others. So I think this unbundling is going to help spur investment and high-paying jobs here in the U.S. And the last piece, of course, is security. More than 2 years ago, the FCC launched this effort to make sure that universal service dollars aren't going to insecure network equipment. And a lot of smaller rural carriers felt like they had no option other than expensive, bespoke pieces of Huawei gear. And that Huawei gear was relatively affordable for them for a lot of reasons, including subsidies from the Communist Party, and including what we perceive to be some security threats that are there. So the question for them is, how do we make sure that they feel like they have more choices and more affordable choices for secure equipment? And that's where O-RAN is going to help out as well. You've got a lot of US-based providers that are expert on software that can create a secure network environment virtually, something outside of a vertically integrated and what we would view as insecure Huawei gear. And so looking forward, I think the big challenge for us and the opportunity from Chairman Pai convening this forum is to accelerate this transition to O-RAN. And we want the private sector to have confidence that they can put this equipment and this software into their networks. One backstop that we have in mind, of course, is this rip and replace that we may engage in here in the US, with it costing roughly $1 to $2 billion to make sure we have all subsidized Huawei gear out of the network. We as policymakers need to accelerate this transition to O-RAN so that these smaller providers, when they're looking to use those rip and replace dollars, feel like they have a real choice, and O-RAN vendors have a fair shot at competing for their business. So that's one backstop in the back of all of our minds for accelerating this transition, and we are really excited about the disruption that's going to come from unbundling the network, and so really look forward to hearing from the panelists today. Thanks.
Thank you so much, Commissioner Carr, for those remarks. We have a great lineup today. Panelists, please turn on your cameras. And in alphabetical order, I'd like to introduce them. We have Cristiano Amon from Qualcomm. I hope I pronounced that correctly. Craig Farrell from IBM. Peter Gamble from Global Foundries. Morgan Kirk from CommScope. Diane Ronaldo from the Open RAN Policy Coalition. John Rose from Dell. Miriam Sarund from Cable Labs, and Soma Valayutham from NVIDIA. And if you'd like to read more about those panelists, you can go to fcc.gov/events, click on the O-RAN page, scroll to the bottom, and we have their bios. But we want to take time today to focus on questions. So let's kick things off. We've heard a lot about O-RAN in the previous panel. We got an introduction to the topic. Morgan, let's start with you. What changes does Open RAN introduce into the current business model for telecom infrastructure?
Yes, well, thank you for having me here today. The current business model has not changed in at least 20 years fundamentally. This has limited the opportunity for innovation, global competition. In the current system, competition is really limited to a once-a-decade competition during a transition of a cycle between 3G and 4G, 4G and 5G. After which the small winners, there are usually two of them, are locked in for that full cycle. This concentration provides a level of stability, but it has a protracted and incremental limit to innovation. And there's little opportunity for cost reduction. So what Open RAN would really do is change all of that. And if I could have my slide popped up, it's probably easy to discuss it based on this. What you see in this slide is effectively a number of interfaces being defined, which allows for competition in each one of the subcomponents, whether it's the central unit, the distributed unit, or the remote unit or active antennas. In addition, what you see on this is an opportunity to change something which has previously been monolithic, in other words, integrated entirely in both hardware and software from a single company, to being disaggregated or open. And that's really the key to all of this. You can have a variety of competitors competing both on cost as well as on innovation in each one of these components. And as we know, when companies are able to compete, they're able to innovate more rapidly. I have here a example, just so that people can see this, of a CommScope remote unit with integrated active antenna. And this particular remote is an indoor remote, but it fundamentally is compatible to O-RAN and would work with other parties' DUs or distributed units or centralized units, thus enabling a company like CommScope to compete in an area which we happen to be good at and have somebody else compete in an area that they're particularly good at. And when you have a full industry that is competing in all these various areas, you will end up creating a more stable, more fast-moving, more dynamic infrastructure that ultimately not only benefits the consumer, but the industry and US manufacturers like CommScope. I like to say that if Companies in the United States are given the opportunity to compete on an open playing field like O-RAN. We do very well across the globe.
Thank you, Morgan. Diane, I want to move over to you. Morgan talked about, diversity, competition. His slide shows how when you disaggregate the network equipment from the core to the edge, from hardware to software, you necessarily are going to introduce new names into the mix, maybe names that were not previously associated with network equipment. So your organization, the Open RAN Policy Coalition, has a diverse membership that kind of represents that dynamic. What does your organization say about the diversity of the radio access network market now as opposed to maybe 10 or even 5 years ago? I think you're on mute.
Of course, it's always me. I'm the first one to leave it on mute. Thanks, Evan. I appreciate the opportunity to be with you here today. And just to say to the chairman's remarks, I hope at some point we can all have lunch at the FCC building. It would be good to connect everyone face to face. Absolutely. We are all here today. You have assembled such an impressive group of government folks as well as private sector experts to talk about how do we drive more diversity and ensure a more robust supply chain. And that's what we're talking about at the coalition. When we first launched on May 5th, it was twofold. It was one, first and foremost, to educate policymakers on what is occurring in this space. Rakuten, Reliance Jio, Dish Networks in our own backyard, they are building out their networks to O-RAN specifications. It's here, it's occurring. And so what can we do as private sector companies? How can we work with the government to help promote policies to ensure that we have scale and we can continue to promote that innovation that's driving at the component level? While Open RAN itself is a specification and it is not a technology, the technology and the technical evolution is going to occur at the component level, the radio, the hardware, the software. So it's great to bring together such a diverse group of folks here today to talk about what's happening today and what we foresee for the future.
Well, speaking of new names in the network equipment space, John, your company, Dell, is a household name, but not necessarily because of O-RAN. While I would really hope that the vast majority of Americans know about O-RAN, at least after this event, they might not think of O-RAN when they think of Dell, but you're here for a reason. And you've talked about the changing ecosystem in network equipment. The makeup of this panel is certainly an example of that. How do you see these changes evolving?
Yeah, no, thanks very much for having us. Hopefully people are familiar with the brand Dell. We're a little more than PCs these days. We're, I think, the largest infrastructure technology provider in the world, but and we do have a very large service provider business, but we aren't explicitly a player in the legacy of telecom, the radio side. What attracts us to this new ecosystem, and I'll talk about that in a second, is that it isn't just about building the next generation mobile network in the image of 4G, which was primarily driven by consumer consumption and mobile broadband packets over the air. It is, to us, the digital fabric that's ultimately going to sit underneath almost every digital transformation, whether it be smart manufacturing, next generation of transportation, the healthcare, or education ecosystems. Those are areas that Dell has historically been extremely visible and present in, and helping those companies and industries transform. And when you think about where they're going, their users are distributed, their data is distributed, connectivity is critical. And when we look at 5G, if you look at the full promise of it, it is the fabric underneath. Now, the challenge we have right now is that if you look at other big IT and cloud transformations, the ecosystem in 5G is relatively small. If you compare even the number of semiconductor companies emerging in the AI space versus the number of new semiconductor companies emerging in 5G, it's anemic. If you look at the software companies, well, there are some great small startups that are doing great work. If you compare that to the cloud ecosystem, it's 1/1000th of the companies participating. And so our view is in order for 5G to really hit its promise of an open, integrated architecture that is this underpinning of the digital transformation, we have to attract the entire cloud and IT industry into this ecosystem. We have to pull in more semiconductor companies. We have to pull in big system companies like Dell. We obviously have to have software startups, investment in new ecosystems, academia has to scale. Just across the board, whether it's supply or demand, the ecosystem has to get larger. And one of the things we like about things like Open RAN is by decoupling and by allowing modularity and replaceability in the architecture, it introduces white space where innovation can happen, whether it's at a very low-level interface like eCPRI or whether it's at a very high-level abstraction like virtualization. The minute those layers exist, it attracts technology companies to try to find a better way to make that interface work or to make value created at that point. So for us, it's a strategic decision to be part of the 5G ecosystem because the entire IT industry depends on it. But it's also an opportunity to help bring that ecosystem together and turn it into outcomes, which is something Dell does probably better than most people in the world.
Well, thank you, John. And based on your background, it looks like you've literally merged with technology. So congratulations on that achievement. And speaking of backgrounds, we have Miriam joining us from a soundproof studio. So very well done on that front. That's video conferencing. That's a video conferencing super move. Miriam, you've been following this ecosystem for a while. So I figured you'd be great to piggyback on some of the things John said. And when we hear about Open RAN, we almost necessarily associate it with 5G cellular networks. But wireline and wireless are, of course, inextricably linked. And there's a reason that the FCC's 5G Fast Plan has such a emphasis on fiber. So what do wireline networks, whether it's cable or fiber or other wireline networks, see in ORAN?
Great. Well, thank you, Evan, for inviting me to speak at this panel. Certainly exciting. So first, as you correctly alluded to, a wireless network is what transports a total network, is what transports traffic from the wireless part of the 5G radios to the 5G core. Therefore, a network must be looked at end to end in order to design for innovation and future use cases. For example, take low latency, which is one of the pillars of 5G. That needs to be viewed end to end. Solving for the wireless part is not enough. Second, let's not get stuck on 5G itself. 6G, the future generation of 3GPP, is around the corner, and also there are other wireless technologies. So in general, when we're looking at the future network and the future of innovation, we must take into account the convergence of the wired and wireless networks. So what Open RAN, along with virtualized RAN, does is to, as my colleagues have stated before, to decouple software and hardware, break down the radio components into smaller pieces, and therefore this makes it easier to bring together and interoperate the elements of a wired and a wireless network through the use of common hardware platforms. And this is exactly where our members will play a critical role and will leverage Open and Virtual RAN to deploy wireless very efficiently and surgically on top of their existing very robust wired networks.
So we've heard why Open RAN might be good for the network. The title of this panel, of course, is Benefits of Innovation. And what does that mean for the consumer? You know, what does the end user get out of this in addition to the network operator? So Soma, I'd like to turn to you. One of the benefits we associate with 5G is network slicing. This idea that you can have multiple networks within a network. Maybe it's one network for gaming. Maybe it's one for smart cities, one for public safety, et cetera. All the same radios producing different networks, different needs in terms of geography and density. Do open networks, or particularly virtualized networks, make network slicing easier? And what does that mean for the consumer?
Yeah, thanks, Ivan, for having me in the forum. Definitely, you know, as my previous speaker spoke, network slicing basically is about software-defined operations, right? And virtualized RAN makes it definitely easy because you are basically creating, network functions are expressed as building blocks, software building blocks, and and abstracted from the hardware, so you can actually pick and place. But there are three components that actually make up network slicing. One is you need to have software unbundled from the hardware. The second thing is you need to have very good orchestration layer. So you need to be able to make that orchestration because it's already unbundled, so you need to coordinate it. And the third thing is you need to really have very high compute to be able to orchestrate this complexity. So it's almost like you unbundle it, but then you need to be logically one, but physically disintegrated. And that's a lot of coordination, right? And that's what network slicing is all about. And virtualization definitely is, it's in fact, it's not makes it easier, it's a requirement, it's a prerequisite to make network slicing. What's interesting is ORAN takes it to the next level, because ORAN proposes certain interfaces like O1, A1, and E2, which basically it's a part of what they call as a radio intelligent controller. And these interfaces in the radio intelligent controller unbundles it to another level. You don't have to be tied down to a network vendor or someone specific, but you actually can really use the open interfaces and run machine learning and deep learning to further orchestrate it. So let me recap. So I think network slicing, in fact, virtualization is a prerequisite, but Open RAN takes it to the next level. It unbundles the logic from a rules-based to potentially an AI-based logic.
And another benefit that the FCC looks for when we think about innovation in networking is spectral efficiency. The FCC has pushed aggressively to make as much spectrum available for commercial use as possible. In Chairman Pai's opening remarks today, he touched on the 5G FAST plan. But it's no secret that there is very little greenfield spectrum left, essentially spectrum that's not currently being used, and that creates challenges. So how do the technologies you just described help with spectral efficiency through deployment of things like software-defined networking and virtualization? The goal here is essentially to squeeze more juice out of the same lemon. And how do we do that?
Yeah, I think that's probably the best expression of spectral efficiency, right? To squeeze more juice out of the lemon. So I think the number one technology that is being looked at in 5G and beyond is massive MIMO. And massive MIMO truly in a sense of 64 antennas, transmit, receive, maybe even higher. And massive MIMO is very promising, but at the same time, it does have front haul requirements. There's a lot of traffic that you need to go back and forth. So massive MIMO, just massive MIMO alone is not good enough, because you need a lot of rules in order to coordinate that. And the idea is, if you can have virtualization and open interfaces to your antennas, to your open RUs, then the rules engines can be very advanced. So today, the massive MIMO is based on a certain logic and rules, and it's probably written by a handful of people. I would say no more than 100 engineers in the world who understands beamforming and MIMO and coordination and so on. But by really unbundling and opening this up, you are able to use AI and deep learning to do beamforming algorithms, to do multi-point coordination. So these algorithms are very advanced. And one analogy I would use is, if you think about cellular is actually an organic beast, right? It's more of a chemical reaction than a logical expression, right? So it's like making beer with yeast. You don't have a logic. You need to be very reactive and optimize your network based on that. And that is very well suited for AI and deep learning. And that's why we are very excited in NVIDIA, because we have a huge heritage of AI and deep learning, and bringing this into telecoms and 5G and getting the best out of the spectrum is fantastic. So again, Ivan, I would say two things. One is beamforming, one is massive MIMO as the technology, but beyond massive MIMO, using AI and deep learning to make the best out of that, that's the most exciting thing.
Thanks, and that tracks with some of the things we heard about artificial intelligence being enabled by open and virtual networks in the previous panel. Craig, we've also heard a lot today about the importance of integration, and integrators will be an important aspect of ORAN in terms of assuring that equipment and software from diverse suppliers can work together. And can integrators replicate the ease and convenience of a full stack solution, essentially the network in a box that traditional OEMs offer? Do you see an established company like IBM supporting the smaller upstarts in the market that do not necessarily have the scale of the larger companies that we're more familiar with?
Yes, thank you, Evan. And in fact, a number of the speakers today have talked about the importance of the end-to-end integration of a solution, and this will be a critical component. As we start to see an end-to-end solution that's really made up of a number of components from diverse suppliers, this whole idea of interoperability testing is going to be critical to seeing the widespread adoption of ORAN in general. So suppliers like IBM, we have a long history of doing end-to-end integration testing for services in IT, particularly software services in IT. So as O-RAN opens up for us a new market, we look forward to bringing this sort of expertise along. And we have entire practices, around testing and certification. We even has, as a number of people have talked about today, how important security testing will be. We have practices around this sort of thing already. So we really do look forward to this sort of opportunity to bring all that expertise to a whole new market. And this is going to be, very, very important, for the integrity of end-to-end solutions to be maintained, because we all want component vendors to be able to innovate and bring the best of breed solution for their particular area. And the idea of bringing best of breed solutions is the sort of thing, I've been doing for a long time. So we want to do that, but it's absolutely critical that system integrators take the components, do the testing, and ensure the integrity of the end-to-end solution. And just in answer to your second question about, will IBM be working with smaller companies to do this? The answer is absolutely yes. In fact, we already are. There are a number of examples, indeed, some of the companies on the call today we're already working with, at customers. So yes, indeed.
Well, it's now my pleasure to introduce my co-moderator for the panel, Charles Mathias, Associate Bureau Chief of the Wireless Telecommunications Bureau, and he will have some questions for you all. Thank you.
Good morning, everybody. It's a pleasure to see you all. Thank you for participating. I'm glad to emerge from the cloud for this purpose. And one of the things that we are looking at as a potential benefit for O-RAN is innovation in the chip market. And Cristiano Bomgia, I was wondering whether we're hearing a lot about the importance of chips, and I'm wondering whether both for the U.S. economy and from a national security perspective, you have some comments and thoughts about the role that chips will play, the chip market will play in O-RAN, and also how do you see this evolving as the technology develops? I think you're muted. It happens to us all. It's still. Cristiano?
Can you hear me? Can you hear me
Oh,
now?
Now we can.
All right, perfect. I'm on a studio, so I had no control of the mute button. Very happy to be here. Thank you for participating in this event. I think this is an exciting time for the industry. And I want to start answering your question by going back on some of the remarks I think that was made by Commissioner Carr at the beginning. Look, in this industry, what we have seen in everything that got scale, especially when you think about consumer electronics or everything that has, digital and processors on it, it really scaled to disaggregation. And I will say that the American companies did well overall by embracing innovation and disruption, and it's actually a moment we have it right now in front of us. I think an example was provided on the PC. I'll give another example, which one is very near and dear to us. When you look at the phone industry, you look at the phone in itself was vertically integrated. You look at companies in the beginning of cellular like Nokia, Ericsson, Motorola. Then a company like Qualcomm created a platform that you can put, change computing from a desktop to the palm of your hand with the silicon and semiconductor horizontal platform. And you look at what the smartphone is today. And in many cases, the smartphone has been the first time that many people in the globe had access to the internet. And it's cannot even measure, I think, the amount of innovation it created. The smartphone today, it's mankind's largest development platform. But the internet also evolved exactly the same way. If you look at the data center today, it's the same thing. And I'll say, by American companies embracing innovation first, I think American companies done very well. Look at the role of American companies in the horizontal personal computing platform, both in the OS as the semiconductor and the processor. You look at that in the phone space, you look at that in the cloud, and it will be no different in the network. The network is going through a process of disaggregation. And I think what's great about this panel, what is great about the FCC initiative, it's about not only bring awareness, but a huge drive for, American companies and companies around the world to embrace innovation and going to what the infrastructure 2.0 is. And with that, I'll start answering your question to say it's fundamental for you to create a horizontal semiconductor platform for that to happen. So we're excited about this opportunity, especially for a company like Qualcomm that has been super focused in wireless communication. Assets that today you only see companies like Ericsson, companies like Huawei for their markets that you have on the digital side and on RF side. A company like Qualcomm that has done that for the device space. It's our number one core competence, and we can create a horizontal semiconductor platform that touches on not only the baseband, for the digital units, but all the way on all of the solutions for the remote unit, and then allow this entire industry to innovate by building new hardware and software and drive this transition to what we call the infrastructure 2.0. So we're very excited about this. We have started early with this vision. I think Rakuten, I think Soteric in the prior panel was the world's first public, network, which is based on a vRAN and Open RAN architecture, enabled by our technologies. And there's a lot more coming from Qualcomm very, very soon in building a very competitive horizontal, platform to enable many companies to innovate in the space and drive this disaggregation of the RAN in the same way that was successfully done within personal computing, the smartphone, and the cloud.
Thank you. Peter, I wonder whether you have share that perspective or have a different view.
Thank you, Charles. First of all, I think with the speed of innovation, I look forward to joining the next panel by my virtualized avatar telepresence. I know that we can do this. In fact, even though we're talking about Open RAN today, the innovation speed is not where it needs to be. Our current forecast is only 10% of the network will be Open RAN by 2025. We all need to work together to accelerate that. And I know that's what's common to a lot of the panelists. We're seeing an explosion of companies optimizing their hardware by the specific function in the network. Many of them are represented today. Two specific examples we already heard are beamformers, where there are a variety of US companies looking at both analog and digital beamformers. And also on the networking side, the explosion of silicon photonics to interface directly to the cloud. At GlobalFoundries, that really allows us to optimize the technology to meet the segmentation in the network. And the second thing we need to do, where we're not quite there, we talk a lot about the interface standards, but in many of our chips, the interface standard itself is provided by a third-party IP provider. The stability of those interface standards and the availability of them in specific technology nodes also needs to be accelerated, and that's something that we're very, very eager to work with our partners on. Once you have interface standards, one of the things we can offer and hardware companies can offer is a root of trust or physically unclonable functions. One is concerned when you have hardware coming from many vendors that will be less secure. In fact, with PUF and root of trust, you can actually have those functions be more secure. The final thing I'd like to just mention is also the opportunity and the role of the US government. We talk a lot about security. Many of the hardware companies are US companies coming in. We have many of them represented today. But if you take it one step lower and look at the chip making industry, right now there's only one US supplier of chips. That would be GlobalFoundries. The rest of the chip making industry is offshore. And we have been working with the US government to ensure that there's a robust supply of silicon from onshore suppliers.
That's great, and thank you very much. All of this sounds like this is going to require a staggering investment. And Diane, I'm curious, at least recently, I think it's fair to say that telecom equipment hasn't attracted a lot of attention from the venture capital market, especially when you compare it to the kind of money that we see going into software startups in the Valley and in other places around the world. Do you see O-RAN changing that? You did it again.
Sorry about that. Absolutely. With a closed proprietary system, the barrier to entry is just so high that we haven't seen much venture capital money in this space. To be a startup company and to make an investment of time, brain power, funding to get a product ready and to only be able to sell to a handful of companies, it was just too risky of work. But when you open up those interfaces, you're injecting that additional competition, which is going to drive innovation. It's going to bring more VC money back to the telecom space. We're moving to the next generation of networks based on the open interfaces and protocols. So it's pretty amazing to watch unfold and in such a short period of time.
Can I comment on that as well? Because certainly in the Foundry, we are seeing quite a few US-based startup companies that are focused on specific segments of the network infrastructure. And as I said, as was said here, made available because now you're allowed to optimize your solution for a particular piece of the segment. So many of the networking companies, beamforming companies are very much startup companies, and we're seeing quite a few entrants from the U.S. venture-backed community within some segments of the network, and again, accelerated by the Open RAN standards.
Mariam, would you agree from your perspective? Is this what you're beginning to see as well?
Look, I mean, let's say there's three things that today are bringing us all here together, right? And that's where we're getting all this diversity that everybody is talking about. It's disaggregating the network into the smaller pieces. It's the opening their interfaces. And the third one is the decoupling of the hardware from the software. So the makeup of this panel and all of today is a testament to that, right? So basically, I'm very encouraged by what I see so far. I see the smaller companies joining the ecosystem. This will definitely foster healthy competition and drive innovation. This will definitely, you'll see a lot of movement in the economics and investments around this. And I'd like to see more on more focus on converged networks. But yeah, I'm very encouraged by this.
Thank you, John. As you know, one of our jobs at the FCC is to help facilitate 5G network deployment. This is one of the things we spend a lot of time on, so that consumers can reap the benefit of the new applications and use cases that will run the network. And I think you're in a unique position to tell us whether you see a startup environment developing around 5G and what do you think the role of O-RAN will play in that?
Yeah, I think not to be negative, but maybe to be realistic, we are not where we need to be. The U.S. vacated the wireless industry with the exception of some semiconductor companies and the actual operators over the last decade. We have now woken up to that and realized this is a strategic technology. And it was, I think everybody's got that message in the opening comments. And now we're in the process of rebuilding an industry. We're not just tweaking it. We're literally have entire areas like large-scale systems integration or the ability to put all of these pieces together into a system that, quite frankly, existing companies and new companies have to step into those roles. And so there's quite a long journey in front of us. So I think we're moving a lot faster than previous generations. But in order to do that, we have to recognize that there's kind of two paths. There's a path to rebuild the legacy of telecom. Wrong path. I was there before at Nortel and other companies, and that's not going to win. Or the other path is to take what we've learned in the cloud and IT ecosystem and build the ecosystem that way. And if you look at that ecosystem, it requires a number of pillars. It absolutely requires at-scale players to put the pieces together. That's what companies like IBM and Dell and Microsoft and many big companies do. By definition, we thrive when there is an ecosystem of innovation that can feed into those engines. But the second piece is we still have a lot of work to do to reestablish the startup ecosystem. About 2 years ago, I went out and talked to VC firms and asked them, well, what are you doing in 5G? And the answer uniformly was nothing. And the main reason was there were no exits. I can invest in this company, but even if they build a successful, radio resource algorithm, who do you sell it to? Where do you use it? And so I think O-RAN has started to open up some of that avenue, but it's insufficient by itself. We will need anchors, meaning large companies that can deliver the systemness of 5G. We will need open interfaces and access points, the three that Miriam described that I think are very accurate. And those are happening, but they will take time. And then lastly, we're going to have to catalyze an industry of startups that will take advantage of them. Now, there's promising early indications. We have seen a number of very interesting kind of radio resource management companies. Every one of them we ran into were so happy to talk to somebody other than an incumbent when we talked to them, because they felt like, well, I only like 3 types of networks I can use this algorithm in, and the interfaces aren't open, so I can't do this cool stuff I've come up with. A lot of it around advanced beamforming, holographic beamforming, new algorithms, fascinating stuff, but not a lot of them. But now I think they're getting the message that there can be more. On the radio side, we track about 20 open radio suppliers around the world. About half of them are in what we'll call friendly countries. But that's going to be insufficient, because if the FCC continues to do the job it's been doing, which is pretty good, about finding and refarming and reallocating spectrum, we're going to need more radios. You know, let's assume we figure out what to do with 12 gigahertz, for instance. That's a whole new adventure. We're going to need a whole new radio ecosystem around it, and we're going to need startups that provide that innovation to take advantage of those bands. So I'm optimistic, but I'm also realistic to say that we have just begun this journey, and it's actually quite hard for a rural operator to assemble a turnkey outcome in the Open RAN ecosystem today. The good news is we have pretty much everybody at the table. The bad news is we have a lot of work to do. The opportunity for government, however, is to help us do that, to invest in that outcome as opposed to the individual components, to really focus on the prize, which is when we're all done, there's a US ecosystem that is dominant around the next generation of wireless. And we don't have that today, but if we all focus on that, we will get to a very interesting place, and all the tools necessary to do it exist.
And I can just pick up on this for a second on what John's point. One of the dangers we face is that if a number of small, highly innovative companies get together but are only loosely compliant with the O-RAN standards and specifications, we run the risk of making the interoperability problem become significant enough that we don't get the widespread adoption that we all absolutely need. So it's very important that we all look at this. We work very, very hard to not allow this this market to fracture into a whole bunch of sort of loosely compliant component vendors, because then what we all want simply won't happen.
So it's an interesting and I think important point as you sort of look back at Unix and where that went and other things. What do you think are the Craig, are the areas, the key U.S. technologies or areas of leadership that are likely to be most advanced by O-RAN?
Well, there are a number, and in fact, in all deference to my fellow speakers, and there's a lot of today who are all working on some really important technologies that I think will advance. But from my perspective, I actually think that we'll see a lot of advancement in and around cloud technology in particular. Okay, we're already seeing things like data plane development kit, DBDK and single root I/O virtualization, this SRIOV thing. We're seeing non-uniform memory access, this NUMA thing. We're seeing, and of course, a number of security features being added around virtual private clouds. I mean, I think you're going to see cloud platforms, certainly from my perspective, which is a key US technology. I think you are going to see that really evolve to support the sort of requirements that networking on a cloud and indeed virtual RAN networking is going to place on those cloud platforms. This idea of high-speed packet processing and high I/O data rates. I think we will see cloud in particular evolve to support those sort of requirements.
Thank you. And I'm curious, are there any particular barriers, and Morgan, I'd be interested in seeing what barriers to O-RAN adoption you've seen and what you think. We've alluded to this in several different contexts before, but what is the role that the U.S. government, other governments can play in promoting it if you think that there's a need to do something?
Yeah, so there's a lot to be done before O-RAN becomes, I'll call it the de facto deployment methodology. I think what was said earlier by John was right now we're on a run rate of only 10% of networks being O-RAN compliant by 2025. halfway through the decade. And this really has to do with incumbency, maturity, and continuing development costs, I think. Networks cost billions of dollars to roll out. They take a decade to roll out, and they are kept for at least 2 decades. And so an incumbency position is incredibly powerful and keeps people within this sort of ecosystem. The other challenge that people have is that the standard being not quite the standard, sort of this breaking up of the standard so that you don't truly have interoperability. And I think for that to be successful, we will have to have, I'll call it plug fests. We'll have to have system integrators in ways that we haven't had before, the likes of IBM and Dell on this call, in a way of de-risking the situation for the operators or the network owners in general, because they're going to be both operators that sell to others as well as folks who run networks for themselves. I think that in order to be successful, governments can do a couple of things. They can put their money where their mouth is. So as was discussed earlier, we can have federal agencies, we can have dollars that are taxpayer dollars required to be part of an O-RAN compliant network to sort of start this cycle going. The second thing that the government could do is offer investment credits, de-risk the risk of developing all of these various pieces to jumpstart the ecosystem as a whole, from very small companies to larger companies, because it's a very expensive proposition to develop a lot of this. And if you're going to have relatively small market share for years, that makes it challenging to have the return on investment that you need. I think that other countries will typically do the same thing. They can support open R&D investments and encourage the adoption of Open RAN compliant networks in their jurisdictions, like we've seen in Japan, like we're likely to see in India and other places in Europe, along with the US. And I think that I'd make O-RAN analogous to the free market and the promotion of the free market. Each country can stimulate this free market, this O-RAN, slightly differently, as long as everybody is working toward that common goal of a level playing field. And what we've seen with the free market, and I expect to see here, is extraordinary results as long as that playing field remains open, because you can create an ecosystem that is better than any type of monolithic ecosystem that can exist.
Thank you. You know, it's interesting because a lot of the time at the FCC, we hear people say, government, keep out of our business. And what you have described is a little bit of tension, because you're saying take a more proactive role, but also step back. And so is there consensus on the panel about this?
If I could just add on that, if I could just add one thing before you put it the rest of the panel. I think that's because the playing field is not level with a variety of companies or countries supporting specific vendors. If no one was supporting anybody, I would totally say your former case, stay out in effect.
Cristiano.
Yeah, I would add to that. This is Soma here. So what I would definitely agree that, you know, the FCC needs to take, or government needs to take a more active role. One, it's a strategic industry. It's just not any industry, right? This is a fabric of the next industrial revolution. Everything that we do is going to be connected. So it is a strategic industry. And the second thing is, you know, spectrum is a national asset. Whether we like it or not, government is already involved. It's a national asset, and we want to make sure that it's utilized to the best. So one of my wish is that if FCC and the government would have an incentive tied to the spectrum, saying that if you want to have these spectrums, either you get credit for using O-RAN, or, you know, some kind of alignment and incentives, because the level, it's not a level playing field, as Kurt was saying. You know, you're actually against a 40-year-old industry, 40-year-old incumbency, and you need to help get over that hump. But once we are there, I mean, ecosystem is hard to beat, but it's also hard to create.
Cristiano.
Yes, no, I like to, this is an excellent, I think, conversation, and I'd like to make a few points, and I think it's consistent, I think, some of the conversations, I think, that John mentioned, and also, this issue about, was discussed about having a system that is consistent. And governments can play a very important role. This is a different thing than building, a new consumer electronics device, right? So the nature of the telecom network is no different than the power grid. And more important than ever, 5G is actually enable a lot of mission critical capabilities. So we need to look at the following way, especially to drive investment to the sector and for the companies, the key public operators, they have to operate a network. So I think we do this in two ways. One, private deployment of a 5G vRAN, that can happen. It's already happening. It can proliferate to the enterprise, no different than the enterprise building its own PBX and Wi-Fi access points, and drive a lot of cases. We can start with that right now. And then government should put a milestone and seek alliance in about a number of countries. They have the same vision, and in the process of upgrading their telecom infrastructure, whether the United States, the UK, other European countries, the Japan, Korea, and many that align with this view, to put a milestone that will drive the operators to specify the system that is going, or the platforms that is going to enable those open interfaces. And the risk of doing it prematurely, if you want to do it like today, the risk is you end up with a non-compliant Open RAN. And you start, because those ecosystems take time to develop. So the way we look, usually if you want to change that stat to have more than 10% of all base stations or radio units with Open RAN and vRAN, capabilities in 2025, I think when you start thinking about as soon as 2023, it's to basically drive requirements and timelines and incentives for the public operators to specify right now, as they get RFP outs, their next generation infrastructure that will come in with, and then with all the right interfaces, and that get done by the tier one global operators in a organized and harmonized way. And governments can play a very important role aligning that timeline and driving the requirements, because then, as John outlined, you're going to create a huge ecosystem that's going to be investing towards 2021, 22, started to launch those systems in 23. There's going to be a lot of exit opportunities for a lot of startup companies to build all the pieces together, and then you have the major operators in the world driving this. If we don't do this in an organized manner, I think we can start with a very fast innovation now in the private sector and private 5G networks. That's going to be incredible starting right now. But then we need to use this as our subsidy to drive the next generation networks, and then we're going to end up with a true, the private sector is very good about doing standards like the 5G standards, great example. We're going to end up with a true Open RAN, even RAN innovation. So very important, I think, to have that coordination and to drive that, because this industry is like the energy sector. The airplane is flying, and you have to do this changes mid-air. So and we can get there by acting in that way.
Go ahead. Yes.
Cristiano, I think that's a fantastic timeline. I honestly think, even 2023 it's probably the fastest you could do, but it's going to be challenging. What we haven't discussed today is the wide range of companies who are starting to deploy non-terrestrial networks, including low Earth orbit satellites and another variety. The need to get those into the Open RAN infrastructure is imminent. And again, usually people talk about Open RAN within the traditional wireless networks, but the excitement around non-terrestrial networks is quite palpable in our industry.
Cristiano, would you agree? One of the things I noticed your focus was on working with the major national network carriers, but we've been making a lot of spectrum available at the FCC that analysts say could be used by private networks or for Internet of Things. Is there a role there for pushing O-RAN principles, or is that really too sliced, as you might say, to make it a relevant force?
No, absolutely. And it's happening right now. And I think that's what is going to drive a lot of the development and innovation, as I said in the prior comment, which will then enable this technology to be, mature for a major shift of the tier one operators to their next generation Open RAN. And I think the key to that technology development is to accelerate into private networks right now. I think, governments around the world are making spectrum available for private users. I think the FCC has done a great job with the CBRS spectrum. I think we have, the PAL, the GAA, and those are going to enable private deployments. And private deployments is very important because actually it's the true promise of 5G. For digital transformation of enterprises. It's easy to see, when the pandemic, happened, we all went home and started to get connected to like Teams we're doing right now. And we're very fortunate in our company because we drink our own Kool-Aid, but many other companies realize a lot of their assets, other than people, were not connected. And it's accelerating digital transformation for you to connect everything. And that happens as you bring 5G to the enterprise. I'll give you a very simple example. If we're doing Teams right now and people are collaborating in OneDrive and you don't have access to your papers, right? You're starting to see more and more that the hard drives moving to the cloud, the IT infrastructure entirely is moving to the cloud. You're connected 100% of the time. You don't have access to a workstation. You use a high bandwidth to do that on the cloud, so we're going to see 5G going not only to manufacturing robots, but to the enterprise in itself. And that it's going to happen to private networks and spectrum available for those private deployments.
Thank you. Mariam, are you gesturing?
Oh, sure. Sorry. I could add to that. I mean, I think I completely agree. That's my earlier point that networks need to be looked at beyond just what we're calling 5G today, whether it's the satellite, whether it's the wired network, it's an end-to-end. I mean, look, so I've been a fan of Open RAN and virtualized RAN since the early days. I just want to note that when I came to CableLabs a year ago, I could tell you that the first thing I realized that CableLabs has been at the forefront of developing multiple generations of open and interoperable communication. So this is not a first. Okay, it's just a first maybe for RAN. The core network was done before. So we've done this before, and we know that Open RAN is not only possible, but it's also an evolution of the radio access network. So I just wanted to mention that every innovation is going to have its early stage. This has its early stages, but it will definitely happen. And we need to look at a broader view of how these open and interoperable infrastructures and specifications will help the entire communication system.
Thank you. Diane, we've been talking about. John, would you like to follow up on that point?
Yeah, just one, maybe snarky point. Not only have we done this before, but the telecommunications wireless industry is the last one we haven't done it to. We have done this to compute, to storage, to networking, to virtualization, to application delivery, to software development. The one that's the outlier that isn't in this modern format is telecom. It is things like wireless. So not only have we done it, but if we didn't do it, this would continue to be an anomaly. And so it's very likely we've figured out how to do this, and we will do it. And then we'll have what I describe as wireless as a first-class citizen of the cloud era, which it is not today.
That wasn't too snarky.
Yeah, well, some people might put it that way.
Diana, so we've talked about all the positive things. I wonder whether you have a sense of the things that we would lose out on if we don't promote O-RAN and move in that direction.
Sure, and I think the one theme that we hear time and time again is we're jumping to that next generation of networks. It's the optimization, it's the customization, it's the things we haven't even thought of yet. Whether you're building out a network in New York City or my small hometown of Rumford, Maine, which is population 5,000, you really need a network that's going to be best for the customer base. And that's what we're talking about here. We're talking about opening things up, driving competition, driving innovation. we are taking a leap ahead. And just to go back to your last question about how governments and the private sector can work together, that's why the coalition came together. We came together to promote policies and initiatives that help take that next step, whether it be public-private partnerships, research and development money, or education events such as these that helps bring together a wide swath of the private sector to discuss what they're doing in this space and how they're taking networks to the next level.
Go ahead.
Yeah, if I could add to that, I think that if this is not done, we're missing this giant opportunity. The next generation of wireless is all about efficiency. It's driving down the cost per bit per area, if you like, covered. And without driving that down, all of those use cases that we have that we can consider today, or the things that we might not have considered yet, simply won't exist. I think this is necessary beyond what we're thinking about today. I mean, can you imagine 20 years ago if we would have thought everybody would have been streaming today, and all of the opportunities for additional channels like the one we're on today being available, this sort of democratization of, I'll call it, television content. We have so many things that get enabled by an opportunity to innovate and an opportunity to really take an ecosystem that was closed and fairly slow moving and create a very, very fast moving ecosystem. I just think it's an absolute necessity to happen if we want to enable what the future of wireless is going to be.
Soma, you had a point?
Yes, I do. It's not just about cost and efficiency. I think it's really the new innovation that's going to open up. I call it, this is the iPhone moment of cellular networks, right? We are just about to cross over. I mean, just imagine the things we can do with all the things in the iPhone, and the same thing we could do with the networks. And when you say what would we lose out, I believe that AI is the next industrial revolution. I think everybody agrees to that. This is about national productivity. How could you have a car factory being highly optimized? You do not have to outsource jobs. When you have AI, you do not have to outsource call centers outside the US. And bringing all AI and 5G is going to work hand in hand. This whole next level of productivity and automation is very dependent on AI and 5G. So that's why I think, it's not just about the next level of connectivity, it's actually the next industrial revolution really depends on AI and 5G. So that's why we really have to take a proactive approach in this.
Thank you. So go ahead.
Just to pick up on Soma's point there, we heard an example this morning from Tariq of what AI was able to do with some spectrum efficiencies. But if you start to see how AI could be sprinkled into all the different components along the end-to-end solution, we barely touched the surface of what AI is capable of doing in every one of these components. So if we miss out on that opportunity, it will be expensive, and it will be less efficient, and frankly, we won't realize the sort of potential that so many of us are looking forward to from this.
So this is a great way to end our conversation. We're almost out of time, and as a lightning round to conclude this panel, I wanted to ask, is this an all-play opportunity? What are the top potential innovations that each of you see resulting from O-RAN? Go ahead.
You want me to go first? I'll go first. So I talked about convergence, earlier. Now, what does that do? It solves both practical and interesting use cases as I was sitting here and talking to you guys and realizing what's happening. So the practical problem is around the seamless user experience. Simply, if I can take this call from my desktop right now, transfer it to my mobile device seamlessly so I can run upstairs and tell my kindergartner who's sitting through a virtual class once again how to unmute her audio and seamlessly come back down here and talk to you guys, right? That's the practical solutions, not very in anything fancy. But it will also, this convergence will also enable the future of things like we talked about today, autonomous vehicles, which require ultra reliability, AR and VR, which require end-to-end low latency. That's what excites me about it.
John, you had something.
Yeah, there's all the normal ones, but the one I'm excited about is this idea of collaborative compute. As we smartify the world, as we make devices intelligent, they have finite power and finite compute capacity. And they, in order to do just spectacular things, they need access to abundant resources. Today, those abundant resources are somewhere else. They're often public clouds far away and out of the real-time boundary. But as we build out edge environments, as we build cellular environments that have mobile edge compute and other capabilities, and more importantly, are open, that we can innovate in that ecosystem and add functionality to the network that is literally within 1 to 5 milliseconds of the compute device, we can do things like have collections of cars and roads work together to see around corners, to do smart agriculture where backhaul isn't the problem because the AI engine is actually in the cell site near the devices. All of these things are exciting. I mean, we're the largest provider of compute devices in the world, I think, today. And we're excited about this idea that if we have this kind of network innovation going on, and we can land compute close to all of those devices, they can exceed their raw potential in really interesting, innovative ways. And so, that is a super high demanding requirement, but it's super important for the 5G environment to be a party of that ecosystem, not an independent ecosystem.
Peter, Morgan, and then maybe who else? We'll see who else has it.
Yeah, I'll start by saying, obviously, the Industry 4.0 is one of the things in the semi industry we see as a tremendous opportunity for 5G and Open RAN and 6G beyond it. Already our demos in the clean rooms with operators using AR goggles to completely free up their hands and service equipment. It's unbelievable what you can do, and the opportunity to bring manufacturing back to the US as you put more intelligence onto the factory floor. That said, I'll quote the previous chairman of the FCC, Tom Wheeler, who said, really our goal is to deploy an agile, fast, and low latency network. No one envisioned Uber when 4G was being deployed. I think the opportunities are going to be in places where we can't even imagine it. Once you put this kind of flexibility in the hands of app developers, software developers, and hardware developers.
Thank you, Morgan.
So I'll bring it a little bit closer and then go far out. I think this is an opportunity to help close the digital divide, making these systems available to you wherever you are, whenever you are. And in a more future sense, and it kind of ties in with where you are in creating an environment. And I say this not just because I love Star Trek and my last name is Kirk, but I think there's a step well beyond, a VR or an AR goggle to light fields, to hollow rooms, to things that we haven't invented yet today, but will fundamentally change the way we work and interact with each other and collaborate, not just within the wireless industry, but across all industries in new and meaningful ways, specifically when we are geographically separated, as we are, in fact, in these times.
Thank you, Cristiano.
Yeah, I'd like to answer that question maybe with a different angle, right? I think there's an incredible amount of new services, opportunities, and some yet to be invented with 5G. When we develop a technology like 5G, we know it has to last a decade at least, and there's going to be huge potential for innovation. What I'm going to answer your question is, we saw that a lot of innovation came to the telecom space in many cases to applications. And I feel that what's going to happen with Open RAN, it's an opportunity back for the telecom sector and the telecom players to innovate. What the thing that Open RAN will do on innovation, it will change how development is done. So it will change the paradigm shift from having maybe one software release per year that all features get prioritized by the vendors. And then once you finally get the feature, you cannot commercialize because the billing system doesn't support it, right? That's what happens in the telecom sector today. And Open RAN is going to change that. Open RAN and vRAN is going to change that and allow innovation to happen like it happens on the cloud, how it happened on PCs and smartphones, and that great news, I think, for the telecom sector, and all of those features and the full potential and the vision of 5G will be able to be realized.
Yes, sir. Soma.
So I would end with saying 4G was about smartphones, cloud computing, and and of course 4G connectivity, mobile broadband. 5G is about IoT. It's not just smartphone, but smart everything. Your smart cars, your smart factories and smart robots, but not smart everything, 5G connectivity and AI. So these three things, as previously John said, the whole ecosystem is going to take it to the next level of productivity and automation.
So I'd like to, we're cutting into your lunchtime, and I'm conscious of that. Thank you all for a very stimulating and exciting panel discussion. Appreciate all of your input. Now I'd like to turn it over back to Evan to conclude. Thank you all very much.
Thank you.
Thank you.
Thanks, Charles.
Thank you. Thank you.
Well, thank you all for participating in what was a fascinating panel. I didn't think I could be any more excited about this technology than I already was, but you have all achieved that. So you have at least one fan here. So please enjoy your lunch. I hope it's a physical lunch and not a virtual lunch. This is one thing that we should not virtualize, which is food. And there's your dad joke for the day. At 1:40 p.m., we will have another fantastic panel, lessons from the field. Where do we go from here? We'll hear from operators who are currently deploying this technology in the field and what they've learned and how we can take those lessons going forward. And that panel will be moderated by Chairman Pai, and it will begin with opening remarks from Commissioner O'Reilly. Thank you all.